I'm Colleen, and I'm a member of our safety committee here on campus. In addition to myself, we have our faculty representative, Vatsala, and Ranjit, who's in charge of lab support here. And the three of us comprise your safety team here on the campus. Contact any of us for any of your needs. You can write to us by writing to safety at NCBS. And it will go to all three of us. Or you can just come see me because you already have my contact information. I want to give you a brief overview of how I'm going to structure today's class. We'll talk briefly about the campus in general, like fire and health. We'll move into general lab safety, transitioning to chemical safety. There's a 10-minute video that I think is the best video I've ever seen for how to work effectively in the lab. We'll talk some about biological safety. I'll introduce you to our instrumentation team on campus, as well as the lab support team. And after that, I'll pass out the exam, and you'll take the exam. For those of you that don't pass the exam, you'll get a mail informing you that you didn't, and you'll have a time next week scheduled where you need to show up and take it. Most of you, I expect, will pass this exam. You'll get a congratulatory email from me, and you'll stop by my office. And as you notice when you were doing this registration, that I had this yellow piece of paper over where you will sign. This acknowledges, and most importantly, that you are going to follow lab safety procedures in the laboratory. And if not, you risk expulsion. That's what you're signing when you sign it. I will exchange for your signature a certificate that indicates you've completed our class successfully. I'd like to introduce you. You've probably noticed that we have security personnel posted all over our campus. They're here 24/7. We expect you to be courteous to them and show your respect. If they need to see your ID because they don't recognize you, you are expected to show it to them and sign in when you need to. All visitors that visit our campus must sign in with the security office. These people are also our first fire responders. They're all trained here to use our fire extinguishers and the fire hoses that you see. And what's really cool is they're going to provide you with some training on our fire extinguishers. In the event of a fire, please remain calm, but inform others that there is a fire, and assist people that might need help to get to safety. We have an emergency number at our reception number that's only for emergencies at 6666, for emergencies only. If the fire is small, use the correct fire extinguisher or the fire blanket that's located in every laboratory. If the fire's big, evacuate and help others. Close off any sources of air like windows and doors if you can as you flee the fire. Go outside and don't enter the building until you've been cleared to go back in. Every quarter here on our campus, our security department will offer demonstrations of all the fire extinguishers. I think there's 5. What's really cool about this is they will build a fire and they will let you handle a fire extinguisher to see how it works. Please don't make it be an emergency the first time you learn how to use a fire extinguisher. Please make the time to attend this class and learn and be safe. And in your own laboratory, be sure you locate where the fire extinguishers are. We have a health center on campus. Have all of you seen it yet? Yes? No? So this is the Southern Labs here, and on the back side of the Southern Labs to the east, the last building down that road will house our health center. They're open Monday through Saturday, which is great. If you need to see our physiotherapist, she requires a prior appointment. If you want to see a doctor, you just go into the office and the doctor will see you. We also provide counseling services on our campus. And like I've mentioned before, but I want to reinforce because in an emergency it needs to be top in your head. The extension for an emergency is 6666. But you can reach reception at 6001 or 2 or 18 or 19, okay? Also, our canteen is very proud of the hygienic food they serve us, and they want you to know this so that if you have any problems with your stomach and you suspect the canteen, please write to them at canteen. They will test the food. They keep samples of the food. They're very confident in the food they serve us here. Our physiotherapist has seen many of you, and she's requested we insert this slide into our safety talk. Please, when you're working, make sure that you are not hunched over and slouched and working down or up, as she's demonstrated in these little figures. Please keep your eyes lined up with the screen. When you go to pick up a box, use your quads, okay, and not your back for lifting. All right? When you're in the laboratory, and even around the laboratory, do not run or jump. Do not talk on your cell phone in the laboratory. Do not eat or drink. No mouth pipetting is allowed. You may not store food or beverage in the cold room, no matter how convenient that may appear to you. We will remove it. Be sure that you wear safe clothes, lab coats, shoes, closed-toed shoes, pants, shirts, and we recommend that you don't wear socks with sandals. If it's cold, wear a closed-toed shoe. And the reason being is if you spill a chemical on your foot, and that sock is just going to absorb all that chemical and just keep it in close contact with your skin. So please consider always, when you're working in a wet lab, wearing closed-toed shoes. All labs have eye washes, first aid kits, fire blankets, the hard copy of an Msds. I'm going to talk about what an Msds later. An emergency contact list and fire extinguishers. I suspect many of you have never seen a fire blanket before, and so I like to pass it around so that you get an idea of the feeling of a blanket, just like I said with the fire extinguisher. Don't let the emergency be your first experience with one of these. What's handy is these are really good to put out a fire on your person, but they will also handle small fires in the laboratory. So just pass this around, please. The first thing and the most important thing you need to do for health and good lab practice is to wash your hands at all times, regularly, before you work, after you work, before you eat, etc. I like to talk a lot about gloves because many of you like them as a fashion statement, but we don't allow you to do that here. The gloves are only worn in the laboratory and not in any of the public spaces, okay? Don't use these gloves even in your lab for common things like your cell phone or your pipettement. Your pipettement, yes, but the keyboard of a computer, no. Unless the keyboard will have ethidium bromide on it, then you must wear your gloves, okay? No gloves are to be worn. We ask you don't leave them out on your bench top. Don't recycle them, in other words. And all gloves go. Very good. Biohazardous waste, the red biohazard bags, must go. When you wear a pair of gloves, I'd like to demonstrate how to remove them. Take your finger and just top at the very top, because the part with your fingers is probably the dirtiest, right? It's going to have whatever on it. Make a gentle fist and ball it up this way. Grab it into the other glove and do the same thing, just touching right here. Where will I throw these nice, clean, brand new gloves? The red biohazard, yeah. It doesn't go in the normal waste, even though it was only used for a demonstration. Okay, when you work in a laboratory, make sure that you disinfect the area before and after. Clean up after yourself and leave it even cleaner than you found it. When you go to do work in another lab, because many of us share equipment and you will be doing this, make sure that you go prepared, okay? And when you go prepared, that means you put everything in a tub. And I know a gentleman who goes from Southern Labs over to Eastern Labs, and he takes 23 items every time he goes. because you don't want to borrow tips or gloves or anything. That's your responsibility when you're borrowing that equipment, that you go prepared. Okay? Inform a lab senior when you run out of chemicals or consumables in the lab, and don't come to work sick unless you're going to the medical center and going straight home. Also be aware that you share your air. It's very obvious here in this new building, the southern labs, because it's one big space. But in the eastern labs, you are also sharing air. So when you're working with solvents, beta-mercaptophenol and acetone, things that are very aromatic, be sure you work in the fume hood. And if your fume hood is not functioning correctly, you will contact lab support. This will come later too. You will likely have to transport samples because our equipment is spread around our whole campus. When you do that, we want you to be thoughtful and consider the route you're going to take. You all know where the canteen is now, presumably, the big canteen here. But right opposite that is our creche. So we ask you not to walk between the canteen and the creche. We don't want the children being exposed to whatever it is you're walking around with. Also, you may not walk with samples through our canteen. Please walk around the long way, okay? You may not wear gloves when you are transporting your samples across campus. Your samples must be placed in a clean tub, as should your gloves and anything else you need when you reach the destination. So as I mentioned to you earlier, Msds, which stands for Material Safety Data Sheet. Every chemical that you purchase will have one of these. Why they're important is if the chemical has toxic properties, they are listed here. They tell you what to do if you get it in your eye, on your skin, or ingest it. So we request every laboratory have a hard copy of these. You don't need to keep the simple salts that are not dangerous, but any of the solvents, anything that will cause you harm, you're expected to have hard copy in the laboratory. You will want to take this to see when you see a doctor. If you've had some exposure that was unexpected, be sure that you carry the Msds with you, or they'll have to locate it at the hospital. Any questions? Am I speaking too fast? Okay, fine. Good. All right. So now we're going to talk a little bit about some chemical safety and handling. When you get a bottle of chemicals and you open it, make sure that you initial it with the date, because everybody needs to know. For example, and this has really happened to me, you can come to a bottle and it's not the expected color. And so you can go ask somebody, when you open that bottle, was it white or was it yellow? It gives us a lot of helpful information. So be sure that you initial it so somebody can contact you. When you make a solution, make sure that you identify what it is, its concentration, and also the date and your initials. When you will need to weigh out a chemical, be sure you use a clean weigh boat and clean weigh paper, okay? Preferably don't just rip out a catalog sheet of paper because you don't know the chemicals that are on that piece of paper, okay? Storage of solvents, acids, and bases is very important because if they mix, it's not going to be a healthy environment for anybody. So we ask you to separate them as much as possible. It's also important that you not store them up high, because if they were to fall down, you'll be splashed from head to toe, as opposed to if they're down low, it's only going to be your feet. So there's less danger by storing things on the lowest shelf, and just keep them as segregated as possible within your laboratory. When you have used up a chemical bottle, but you'd like to use it for other purposes, it's your job to rinse it out 3 times, making sure that it's clean before you pass it along to the lab kitchen people to clean it. Our lab kitchen people are not trained scientists like you are, and so it's your job to keep them safe. Every chemical that has a hazard has these symbols that you should be familiar with so that you know how to handle that chemical and you know the risks involved. Just seeing this symbol will give you a lot of information. Chemical spill kits. They're available at stores, and they should be in every single lab here. They come in different size packaging. This is one example of many. So just look, but they'll all say chemical spill kit on them. Inside are absorbent materials. This one I like particularly because it has this nice way of containing and marking it. If I were to spill a chemical and now I've outlined it here, you're not likely to step inside. So that's why that's great. You all are new here. I don't think you know how to treat a chemical. So you need to get help. Get a lab senior right away. Call the lab support office because they also have training on how to handle a chemical spill. But you might be the first responders. So you need to know that you need to mark the area so no one else can get hurt. Inside a chemical spill kit, lots of absorbent material, okay? Many pads. Also, which I think is fabulous, is they also have heavy-duty gloves, a mask, goggles, as well as bags for collecting the waste you will generate when you absorb chemical that you've spilled. But you are all new here. Please consider getting help. But you should know what a chemical spill kit is. Sometimes chemical spills occur on your body. So you need to know where the closest full body shower is located. Here in the southern labs, it's on the southern corridor on every floor. So it's outside the laboratory area. It's on the opposite side that we're on here. You'll see there's 2 on every floor but the 3rd floor. And there's a stick with a triangle that you pull, and you can stand under that if you have a big spill. You probably won't know how long you need to flush yourself if you spill a chemical. Now we refer back to the Msds that I talked about. This will tell you how long you're flushing, 5 minutes up to an hour. It depends on how risky the chemical is that you've put on your skin and or eyes. When this happens, NCBS has an accident report form. We use this for InStim too, by the way. We want you to fill this out with any spills that occur or any biological hazard that you've been exposed to. Because we need to know what happened. Maybe I need to teach this class a little differently, more effectively. And also, we want to make sure you get the proper medical care. So this accident report form does not get you in trouble. It's an educational tool for you and us and the hospital you go to. This is the movie that I referred to. It will take about 10 minutes. It's the best movie I've ever seen as an introduction to working in a laboratory.
This video promotes chemical safety. One protocol is used to demonstrate the safety principles that apply to working with many of the hazardous chemicals used in the modern biology laboratory. It is intended to supplement the formal instruction provided in each institution and each laboratory. This video is not a substitute for a safety training program. The tools of the modern biology laboratory include an arsenal of chemicals. Knowledge of these substances and respect for the potential hazards will allow the research laboratory worker to practice good science safely.
You know, people who start in the lab have the tendency of being extremely concerned with radioactivity. This is really what they are scared of. Phenol and acids and all that, they are not too concerned about because we know exactly what happens if you pour acid on your hand. But I tend to think that these are actually much more dangerous for the kind of research that we do, where we use low levels of radioactivity most of the time. And that these are the accidents one should really watch for, actually.
Where and how you perform a procedure should be determined by an understanding of the task at hand and the chemicals involved. This morning, Gretchen Hannon is going to prepare a series of DNA samples using phenol chloroform extraction and ethanol precipitation. Her first step is to equilibrate the phenol. The Material Safety Data Sheet is a good source of information about a chemical's hazards. Laboratory workers should be familiar with the relevant ones. The Msds for phenol tells us it is a powerful corrosive and causes serious burns on contact with skin. Gretchen makes sure the phenol is at room temperature before melting it. She also allows for heat expansion in the bottle. Gretchen knows not to put the warm phenol bottle on a cold surface because the glass could crack and allow the phenol to run out. The Msds for tris hydrochloride tells us it may cause irritation of the skin and eyes. Here's an opportunity to avoid splashes. Whenever hazardous chemicals are used, a lab coat, gloves, and safety glasses provide valuable protection. Be alert for the possibility of the stir bar cracking the bottle. A secondary container provides cheap insurance. Phenol is one of the more hazardous substances in the modern biology laboratory. Always consider safer substitute protocols as they are developed. To reduce risk of exposure, Gretchen avoids working with a large bottle of equilibrated phenol by preparing several small stock tubes. When you work with a chemical, consider whether you are doing anything such as heating or combining with other substances that will increase its hazardous nature. Adding chloroform, for example, enhances the ability of phenol to penetrate the skin. Chloroform represents numerous health risks, including cancer and organ damage. It may be harmful by inhalation or skin absorption, and its effects are cumulative. Phenylchloroform extraction in large quantities is best handled in the fume hood because of the inhalation hazard. Gretchen has performed this procedure many times. Otherwise, a dry run would help identify problems she might encounter with the workspace, equipment selection and layout, and with her dexterity. Note how she holds the cap as well as the tube to prevent it from unscrewing. After drawing off the aqueous phase containing the DNA sample, the phenylchloroform goes into an appropriate waste container. Be aware of the splash hazard. With 2 or 3 phenylchloroform extractions, the samples are ready for precipitation of the DNA. Sodium acetate may cause skin and eye irritation on contact. Ethanol's principal hazard is its flammability. When using small volumes of phenylchloroform, it is acceptable to work at the bench. Still, the chemical hazards are real. Snapping of microfuge caps can produce splashing. Gretchen uses her hand to shield herself. And she firmly grasps the cap along with the tube while vortexing. Working with chemicals safely means doing all the things required for doing good science. Know your protocol. Execute procedures meticulously. Know your chemicals. Use smaller quantities of chemicals. Consider safer substitute protocols. Wear safety glasses, gloves, and a lab coat when handling hazardous chemicals. Avoid splash hazards. Use a fume hood when handling stock quantities of volatile hazardous chemicals. Be alert for hazardous situations. Use a healthy dose of common sense. Maintain concentration.
There is clearly a danger that just by habit one will forget and one will become less and less careful. The other thing is that people should not work in the lab when they are exhausted. I mean, I love having people working late at night. That means they are really interested in what they are doing. But on the other hand, you know, one reaches a point where one is just too tired to do an experiment properly. And that is bad for safety. That is also bad for the experiment.
Fatigue is a real serious consideration when you work in a laboratory. You'll see many people are enthusiastic and they do work late at night. But if you're tired, don't start the experiment. It can begin the next day, okay? Keep yourself safe at all times. Some of you, if you work with DNA, might be using ethidium bromide. Most labs we are trying to move away and using the alternatives, such as gel red. But if you do use ethidium, please know that it's a very powerful mutagen. It's very insidious and it's easy to spread everywhere. And that you really should be wearing nitrile gloves. These are the purple ones. They also come in different colors, by the way. But primarily, people tend to use purple to indicate that they are wearing nitrile, because this nitrile is a stronger and less porous substance than latex, which is what the other gloves are that you see commonly. Okay? Also, if you're working with ethidium bromide, you need to visualize your DNA, and you're going to be using a UV box, a transilluminator. You run the risk with UV of some UV exposure, so be aware of that, and make sure that you protect yourself with shielding, such as glasses and a face shield. Those are usually provided right in that area. Also be thinking about like those glasses and the face shield. They probably have ethidium on them. No bare hands, keep those nitrile gloves on, and make sure as soon as you leave that area, you take off your nitrile gloves. And these nitrile gloves that have been in ethidium, they do not go in the biohazard waste. They will actually go into the ethidium bromide waste. Okay? So know the sources. Hoods also have UV light. So if you go to work at a hood, make sure that the light is switched off. You don't want to expose your arms when you're working in a hood to the UV light. Tissue culture rooms and clean rooms also have UV lights. Most of them come with an indicator that has like a red bulb that tells you it's on, but not all. So just protect yourself. When you work with SDS paste gels, you'll be working with acrylamide. That's a powerful neurotoxin. Once again, use your nitrile gloves. Know that you're required to dispose of it only in its polymerized form. No liquid acrylamide is allowed to be disposed of. Follow the directions for how to get rid of your gels and your stain and destain. As you saw in the safety manual, which I hope all of you had a chance to review, we have 12 different bins that we segregate our waste in. The people in your lab are familiar with these segregation rules, and you can ask them. And if they are a little rusty in that, contact the lab support group. Here is a photo from NCBS. What's wrong with this photo? Yeah, Don't mix your waste, and in particular, food should not be in biohazard, although maybe you thought it was, but it isn't. This biohazard waste has to be specially treated, and it costs us a lot more money. So don't unnecessarily put waste in there. We always try to house right next to the red bin a normal dustbin to keep the plastics that your plates come in. Food, of course, should never have been in the laboratory in the first place. So we don't know how those bags got there, but they do not belong there. Here on our campus, we have a BSL 1, 2, and we're actually in the process of building a BSL 3. When you work in a higher level biosafety laboratory, you require additional training. Okay, this class is nowhere near. We are going over an introduction to lab safety for our campus. But you need specific instructions if you're going to be working with biohazardous materials. When you work with biologicals, there's two ways to disinfect: 10% Clorox or 70% ethanol. Make sure that you wash your areas appropriately. If you're working with stainless steel, like in a hood, a biosafety cabinet, don't use bleach because that will actually corrode the metal. Use the 70% ethanol. Make sure that you wash your hands before and after all biological work that you do, and take off your gloves and dispose of them properly in the biohazard waste. I'm going to mention briefly, because it's been called to my attention by many of you, believe it or not, the proper use of a biosafety cabinet or hood. Make sure that when you go to the hood, you clean it thoroughly beforehand with the 70% ethanol. Then you turn on the hood fan and you allow it to flow for at least 5 minutes. I personally go for 15, but that's because I'm more paranoid about those things. It's not necessary to leave the UV light on at all times. And by the way, UV will deteriorate plastic. So if you're storing your tips and your pipettement in there, they will wear down much faster than if you didn't keep them under UV light. Don't store stuff in the hood. So the way your hood works is air circulation. If you block the circulation with junk, I mean, it could be good junk, it's your tips, your tubes, your bottles, but if you block that, then you are losing the ability for that safety cabinet to keep your sample safe and you safe. So make sure that you keep everything at the very minimum inside that hood. And this is the most important thing of all, and she brought it up in the video. Plan your manipulations in advance. And since you are new here, have people watch you. Sterile technique is tough, and you will inadvertently do all kinds of things that will ruin your sample because you're just not as well trained as an experienced person. So practice, practice, practice with dry runs before you risk your samples. When you work with biologicals, check that your container is leak-proof. Look at the glassware if it's glass and see if there's any like stress marks or stars, and don't use that glass, okay? Make sure that when you're transporting it, that you put it in a leak-proof container, just like the woman did in the video. You saw how she put it in a plastic beaker? You're going to be needing to do the same thing to keep yourself safe and all the reagents in your lab safe. We encourage you to avoid needles and syringes as much as possible because that disposal is even more challenging for us to dispose of here. When you work with biological liquids, we ask that you work in a biosafety cabinet so that you aren't inhaling any of the aerosols that you produce when you're working with the liquids. Make sure that you clean that cabinet before and after, all right, using the 10% Clorox or 70% ethanol. When you have an old flask or beaker that has the LB that had some bacteria that you've now spun down, there would still be some residual cells in that LB broth, right? So what you need to do to dispose of it is bring up the volume so it's a 10% bleach solution and swirl it really well and let it sit for half an hour, making sure that that bleach destroys all the living cells inside that liquid. Once that is done, you go to a sink and you turn it on and you allow the water to flow. Then you will slowly pour your solution that's bleach and dead cells and LB down into the drain. When you're done, you'll rinse out your container 3 times with just regular water before you put it in the wash. You also need to let the sink run for a few minutes, okay? Just like 2 or 3. Biological spills are similar to chemical spills in terms of what you need to do. You need to identify the area. You need to ask for help. Okay? You're going to disinfect it differently because, of course, some chemicals can be neutralized, but many cannot. But you're going to disinfect with the 70% ethanol primarily, depending on what surface the biological fluids have fallen onto. Make sure that any spills that you wipe up with this absorbent material are double bagged for autoclaving. Make sure that you fill out the accident report form, and make sure that we help you dispose of everything safely and that you get the safety treatment you need, most important of all. Okay, this is the one to your body. Make sure that you take off your clothes. That's why we encourage you to wear lab coats, because then you just have to remove a lab coat. Make sure you wash very carefully with soap and water for at least a minute or more, depending on what the substance is. Then apply some ethanol very quickly and rinse that ethanol off fast, okay? Obtain the medical attention that you need, taking the Msds with you, and filling out the accident report form after the fact, but so that we can help you. Now I'm going to introduce to you some of our campus support departments that really help you work more effectively in your laboratory. We have lab support, we have instrumentation, we have several facilities on campus that I'm only going to mention at this moment in time because each of them offers their own orientation primarily. SIF, the fly facility, the animal house, sequencing. We have a lot of supporting facilities here on our campus that will require you to know more. This is not going to be covered in the introductory class, but just know that we have an amazing support system that goes on here. We have other offices that can help you. The establishment office is who gives you your ID card. The dean's office, you know, because you've been handling them as you've started to work here. We have security, purchasing, administration, and tech services. We have a lot of people here working to make this campus work effectively. Be sure you show your appreciation and respect to these people that help us. So the Instrumentation Department here maintains all of our instruments and common equipment. What's more important is that they provide us with the training so that we can use that equipment effectively. You're not allowed to use common equipment here without proper training. The proper training is first done with and through instrumentation, but then you're not allowed to just use the equipment by yourself. You have to work with a senior. If you're a summer intern, you're actually not going to be using any equipment here this summer at all by yourself. You're going to be basically job shadowing and watching people who are experienced with these pieces of equipment use that equipment. Okay? Instrumentation will also provide multimedia support, as witnessed by today by me. They help you with your telephones, and they maintain our access control that you see it, especially in our restricted lab areas. You need an ID card that's been approved to go in and out of certain areas. When you need to contact them, INS is the key. So, you have responsibilities when you use equipment here, because not all of you are the summer interns in this group. So you need to realize that the training is going to be required, and that the new students, like I said, have to be supervised. Please read the manual before you use equipment so that you're more familiar, and you'll also be able to ask intelligent questions because you'll have an idea of how the equipment's going to work. Now here's the important thing that's going to come on another slide. You must sign in the logbook, as well as reserve it on the online scheduler. And don't move equipment. If you need equipment moved, you contact instrumentation, and they will move the equipment for you, and they will make sure that it's done so safely. So, like I mentioned, you need to use the logbook and the online scheduler. And there's consequences if you do not follow these two things that you must use when you use common equipment here. Not doing either one of those entitles all of us to enforce it by disposing of your sample. And I just did this 2 weeks ago. Please, please, please be sure that you use both of these ways on equipment. It's very important that you do that. Also, if you're a real If your infraction is serious, we have a committee that will review your actions, and they can suspend your privileges for 1 to 3 months, which could be, the end of your career here. So, logbook, scheduler. Now you're new here. Scheduler you do online. It's your reservation. That way everybody knows who's using what equipment when, and you know it's available for you. You just don't get to hop in and use it. You need to make your reservation. The logbook sits next to the equipment. This is very important for everybody, primarily you. If there's a problem with the piece of equipment, your name is there, and somebody can call you and say, this happened to your sample and or the equipment you're using, so that you can do a rescue, like switching it to another piece of equipment. So that's how it benefits you. It benefits all of us because it tells our instrumentation team how often they've been using this piece of equipment, so they can schedule servicing appropriately. Okay? So make sure you schedule and sign in a logbook. When you need to do repairs, you need to coordinate through the Instrumentation Department. No vendors are allowed to do work. Even if your lab knows the vendor and knows the repairman, please do not contact them directly. Please, please work through instrumentation to get this work done. Case in point, CCAMP was a mercury-free zone. They had nothing in their entire fleet of things there that had mercury. But somebody came to repair some equipment, and that instrument had mercury, and he broke it. So there was a mercury spill in this place that never expected to see mercury. Realize that we have mercury spill kits. They'll be in the lab support office, and we keep them near the chemical spill kits on the first floor here of the Southern Labs. So if it's late at night, lab support is closed, you can get that. If you work with a significant amount of mercury in your laboratory, you can get a kit through stores so that you can do it. The directions in here are awesome. I was involved with a cleanup once. It was my first spill. The directions are very clear, and being that you're new people, enlist support when you do this work. I'd like to talk to you briefly because many of you will use centrifuges, from the very small ones to the very big ones. Make sure when you are centrifuging that your tubes are balanced, not visually, but by weight, okay? Also make sure that they're balanced with their placement in the rotor. So they need to be balanced. You can use 3 as long as you have a space between the 3, right? If it's a 6-slotted thing, it's every other. But balance is critical to the proper operation of a centrifuge. Also make sure that the lid is on tight and the rotor is seated properly on the spindle. The lid itself, often on many pieces of equipment, actually connects your rotor to the spindle. So getting that lid correctly seated is important. This is why training is vital through our instrumentation department, because they will demonstrate this to you and let you use it correctly. When you centrifuge, there's an innate point of imbalance. When they come up to speed, there's sort of this moment where they're slightly imbalanced and they'll make a funny noise. This is why you will not use equipment to start with by yourself. You need to be there with somebody who says, this is just the innate sound, or you haven't balanced something correctly and you need to shut that machine off quickly. I've had to do that before. Make sure that when you use a centrifuge that you stand there until it achieves the speed you've set, because things can go wrong as it's coming up to speed. That's usually when it'll happen more often, and you need to be there to minimize all damages. Okay, don't open any centrifuge until the rotor has stopped rotating. Clean up all your spilled liquids. We keep towels in the rooms to put in the tubs, and all rotors need to be rinsed out with water. They all have little chambers in them. Rinse it out with water and leave this rotor inverted so that it will dry properly. Okay? Does anyone have any questions? Okay. This is my first time teaching this because I ask people always for inputs. And I was told that y'all probably haven't used many micropipetters before you arrived here to NCBS. One of the most important things you can do is use all equipments correctly. And a micropipetter is also one of those. Play with it a while. You'll see that there's different stops. Do you see how my hand stops here, but then can go all the way to the bottom? Learn how these stops operate. The mistake most of us make when we start working is ignoring the importance of properly seating the tip. You'll hear this sound, right? That means I'm seating it so that I get the complete seal and I will have accurate pipetting. You should never spin it above what it's set to go, the minimum and maximum. To move it beyond that will actually, and in some instances, totally break your pipettement. These are fairly expensive pieces of equipment, so use them respectfully. Also, every time you suck up a liquid, before you insert it into the tube, do a visual check. See if it's the right, and you say, well, I've never done this before. So I'm saying to you, practice, practice, practice. Get some water, see what 10 microliters looks like, see what 100 microliters look like. You will save yourself so much grief if you learn to just check your own work as you start working. Good habits at the beginning, yes, it's going to take you longer, but it'll pay off in spades in the long term. So please, please ask for help and use equipment with thought. So we also have another important department that really affects laboratories here, and that's called our lab support. And I'm going to tell you what they do for us. They help our new PIs set up their laboratories. They also manage the lab kitchen. I'm going to tell you all of lab kitchen's responsibilities in the next slide. So just know that they're the people in charge of the lab kitchen people. They also dispose of all the chemicals and all the old equipment that we have on our campus. They do a lot of ordering for us, the oligonucleotides, when you need primers for PCR, all that's done through our lab support office. They stock all of the gases for our labs. They coordinate the facilities, your requests to get facilities. Remember I mentioned we had sieve and sequencing. All that will be coordinated through lab support. And you can contact them, lab support, NCBS. Okay, lab kitchen has a huge list of job responsibilities as well. They clean your glassware. They do your autoclaving. They distribute water, the lab grade water that goes into all of our labs. They're responsible. They distill alcohol for us. They do the common lab area cleanings because the housekeeping people, they have less training than the lab kitchen people. So we train the lab kitchen people minimally for how to work effectively in a lab environment, and in particular cleaning it. They manage our tissue culture labs. They do all of our waste collection, and that's why it's really important to us that you follow all those waste guidelines we give you. These people are not trained scientists, so you need to keep them safe. They know what to do with each different colored bin that you have, but they don't know how to make those decisions. Those decisions are yours. And you can contact them at Lab Kitchen. Okay, as I mentioned earlier, but I like to reinforce it, the accident report form. You need to fill this out with anything that happens that's extraordinary, okay? Feel comfortable doing this. We're not going to blame you. We need the education. We want you safe. I'm done teaching my class. Does anyone have any questions before I talk about the exam? Okay, so this exam is wonderful, and it's challenging for many people for many reasons, but one of them, and the best way you can assure yourself that you will pass this test, is there's two question types. Multiple choice has one answer, and multiple answer has more than one answer. If you forget this, it's written on the exam, so just read it at the top of the page. But follow that guideline. It will certainly help you a lot with passing our test. I'm going to email you the results. Okay, for those of you that arrived late and or emailed me after 2 o'clock today, I kept track of who all wrote to me and just put a little tick mark next to your name, okay? Just check it off. Also, we have these acknowledgement sheets. You can go on any one of the three here because I expected 60, so I expect these will be filled in by the end. Add your name, whose lab you're in, and your ID number if you know it. If you don't know it, it's okay. Do not sign the sheet. The signature will come when you come see me after you successfully complete my class. I'm going to exchange your signature for a certificate that says that you've passed this class. So it just says that you've participated, okay? Be aware that we hold you responsible. You're signing this saying that you've attended this class and you're better aware of our expectations in the laboratory for your safety. Are there any questions now? Okay. After you take the exam, which I don't know how long it would take you, so we kind of allowed an hour, but at 5 o'clock, Mukund will start his ethics conversation with you. Be sure that even though you take the exam and you leave and you maybe go take some tea, be back in this room ready to listen again at 5 o'clock. You have until 5 o'clock to take this exam. Mostly it'll take you 30 to 45 minutes. It sort of depends. There's 30 questions, multiple choice or multiple answer. Okay? And then I've run through the registration details. Make sure that if you came late that you sign in after you turn in your exam. Okay? And you can ask me if you are not clear on an exam question, I'll help you interpret it. For example, I loved it. We had some foreigners here and they didn't know the word pet. I gave you a clue. There's a test question about pets. But they didn't know pet. So you can just ask. I'll help you.